Hello, and welcome to Week 2 of the MUMS 211 fabrication class at Lorain County Community College. This week, we are going to talk about the substrate that is used for production of semiconductor microchips. Last week, we discussed the microelectromechanical systems and their utilization in the semiconductor industry. You already know that MUMS are integrated devices, which combine electronic, electrical, and mechanical components, and that their essential components are semiconductor microchips. In this video, we will focus on the silicon substrates, otherwise known as wafers, from which these microchips are manufactured. So how are these silicon wafers made? The basic material used for production of wafers is silicon. Silicon is made of highly purified and refined sand. The raw silicon material, which is produced this way, consists of multiple crystals. Thus, it is called polysilicon. This polysilicon material is then further processed and made into single crystal silicon ingots. These ingots are columns of ultra-pure silicon. They comprise of a single crystal, which is grown during a special fabrication process, into a single crystal silicon ingot. Next, the ingot is sliced into wafers, which are then used as the substrate to produce semiconductor microchips. Now, let's look at how the raw silicon material, which consists of multiple crystals, is processed into a single crystal ingot. We will look at two methods that are frequently used in the semiconductor industry. The first one is called Czochralski process, and the second is called float zone process. Czochralski process was created by a Polish chemist, Jan Czochralski, in 1918. It is a method to grow single crystal silicon. Highly purified silicon is melted in the temperature of 1500 degrees Celsius. The seed crystal, that is mounted on a rotating shaft, is dipped into the molten silicon. The crystal is counter-rotating and pulled upwards, allowing the formation of a large, single crystal cylindrical column from the melt. This big, single crystalline silicon block is an ingot. Through this method, we can process crystal ingots with a diameter of 300 millimeters and with length of 2 meters. The float zone process is a newer method of making ingots. It uses the same melted silicon, but it also uses magnetic field and coil. The process starts with a polycrystalline ingot. The end of the rod is heated up and melted using a radio frequency heating coil. The melted part is put in contact with the seed crystal, and the atoms realign, after they melt, into the single crystalline state. As the molten zone is moving along the polysilicon rod, the single crystal ingot is growing as well. Finally, once the single crystal ingot is grown, it is then sliced by a very sharp diamond saw into thin wafers. The dicing process is a very delicate operation. The sliced wafer is 775 micrometers thick and 300 millimeters in diameter. Nowadays, wire saws are used more frequently, rather than the previously used blade saws. In fact, the semiconductor industry is now moving to the wire saw, due to their superior technology. This brings us to the end of today's presentation. Today, we have explored the process of making silicon wafers, and two processes for growing single crystal silicon ingots. Thank you for your attention.